Hello everyone and welcome to the course of 5G Core Network by Telcoma. So in this course we are going to discuss about the 5G core network in detail. So let's start with the core network. So services offered by 5G as enhanced mobile broadband. The requirements, they are defined on high data rates. We require higher traffic and connection density, higher user mobility, and also the requirements which are related to various deployments and coverage scenarios. The scenarios addresses like we require different service areas, indoor, outdoor, urban, rural areas, office and home, local and wide area connectivity. And also there is a need of special deployments, for example, massive gatherings, broadcast residential and high-speed vehicles. So scenario and the performance requirements, like for downlink, the experienced data rate of 50 Mbps are expected outdoor, 1 gigabit per second indoor, which is 5G LAN, and half of these values for the uplink. For services to an airplane, a bit rate of 1 to 2 Gbps is expected per plane. Next service as CC and URLLC, which is critical communication and ultra reliable low latency communications. We have several scenarios which require the support of very low latencies and high communication service availability. These are driven by new services like we have industrial automation. The overall service latency totally depends upon the delay of the radio interface, transmission within the 5G system and transmission to a server. And this server may be available outside the 5G system and also the data processing. Some of these factors which depend directly on the 5G system itself, whereas some other factors which can be reduced by suitable interconnection between the 5G system and services or offered on the servers outside the 5G system. For example, to allow local hosting of the services. In context to the remote control for process automation, a reliability of 99.999% is expected with the user experience data rate of up to 100 Mbps and end-to-end latency of 50 milliseconds. This is provided through edge computing. Next we have massive IoT, several scenarios that require very high traffic density of devices. The massive IoT requirements, it includes operational aspects that apply to wider ranges of IoT devices which could be anticipated in the 5G system. We have flexible network operations. We have some specifications which are offered by the 5G system. Offered by 5G system. It covers aspects such as network slicing, network capability exposure, scalability of diverse mobility, security, migration and interworking. The diversity of requirements which are associated with different categories, like it enables the use of 5G by different sectors of industries. So different sectors of industry we refer to as verticals. Like automation and other transport, trains, maritime communication, transport, logistics, Internet of Things, discrete automation, electricity distribution, public safety, health and wellness, smart cities, media and entertainment. So overall architecture of the 5G system, like what are the deployment options for 5G? So we have two deployment options for 5G. First is NSA, which is non-standalone, and another one is standalone. So what is NSA? NSA is non-standalone architecture. Here in this, the 5G radio access network LAN, which is also known as new radio, it is used in conjunction with the existing LTE and evolved packet core network, for example 4G radio and a core, thus making the new 5G based radio technology available without the network replacement. In this architecture, 5G RAN, which is also known as new radio, it is used in conjunction with the existing ones. The NSA is also known as EUTRA, new radio dual connectivity, which is also known as ENDC or architecture option 3. In this configuration, only 4G services are supported, but enjoying the capacity offered by the 5G new radio. So this is a non-standalone architecture. We can say see here eUtron is here in evolved packet core, and this is 5G node Bs. These are connected to LTE core network and LTE base station E node Bs. In this architecture, new radio base station, which is known as logical node or eNGNB, it connects to the LTE base station with the help of X2 interface. X2 is the interface. eUtron for NSA connects to ePC with the help of S1 interface. Dual connectivity between master and secondary node is called ENDC. Next is the option of standalone architecture. Here the new radio is connected to the 5G core network. In this configuration, full set of services are supported. The new radio base station, which is logical GNB, connects to each other via XN interface. The NG RAN for this is connected to the 5G core network with NG interface. We can see here. Two are connected with the XN interface and with the core network with NG interfaces. Next generation interface and XN. Thank you so much.